This is the third video I've done on the energetics, and this is for measuring enthalpy changes. So to measure enthalpy changes, we use calorimetry. The basic setup for this is a polystyrene cup with a thermometer sticked inside. So obviously in the polystyrene cup will be the solutions which are reacting. However, a more precise setup is using a bomb calorimeter, and that's because there's less energy lost to the environment. So the equation for the enthalpy change is Q equals mc delta T. It's easy to remember this as Q equals mcat. And Q is the energy change in joules, and that's important to remember this one's in joules. M is the mass of the environment, so the solutions. C is the specific heat capacity, and that's usually given unless obviously that's what you're trying to find out. And delta T is the change in temperature, and there's no units for this because a change in 20 Kelvin is the same as 20 degrees Celsius being changed. So once you have your value for Q from the above equation, you need to convert Q into kilojoules, and that's why I said it was important to realise that it's in joules earlier. And then what we do is we use the equation delta H equals Q over N, where N is the number of moles. And the final answer for our enthalpy change must be made negative, and that's because enthalpy change in this instance is always an exothermic reaction. And just a couple of notes: when there's two solutions in the environment, the mass that we use for the MCAT equation is the sum of both of the solutions. And the moles that we use for the second equation, the Q over N formula, is we work out the moles for both of the solutions, and then whichever is smaller is the one that we use. And that's because this is the limiting factor. And that's all you need to know for the enthalpy changes measurements.